All right, so get this. We're diving deep today into the world of really big AI,
Oh, yeah.
like way beyond your friendly neighborhood ChatGPT or even Bard.
Yeah.
We're talking about large language models, LLMs, if you're in the know, and what's happening inside them.
Mm-hmm.
Specifically, this research paper we're looking at dives into the intermediate layers of these models.
Okay.
It's like kind of like peeking behind the curtain of a magic show to see how the trick really works.
Exactly. Yeah, these intermediate layers, they're like the hidden cogs and gears of the AI's thought process. You know what I mean?
Right.
We usually only see the final output, right?
Mm-hmm.
But this study is suggesting that what happens in those middle stages is surprisingly important.
Okay, so before we go full-on matrix here,
Right.
can you break down what these LLMs actually are for us simple folk?
Sure, sure. So think of it like this. Imagine you've got this massive library, right?
Okay.
With millions of books on every topic imaginable.
Mm-hmm.
That's basically what an LLM is. It's a giant storehouse of information.
Yeah.
And these intermediate layers are like different sections of the library,
Oh,
each one specializing in processing and refining different types of knowledge.
Got it.
You know.
All right, so I'm picturing like the Dewey Decimal System on steroids here.
Right.
Now, the paper talks about two main types of LLMs, transformers and state space models.
Yes.
Those sound kind of like something out of a sci-fi movie, to be honest.
Well, they might sound intimidating, but the concepts themselves are actually pretty straightforward.
Okay.
So transformers, they're like the super speedy librarians in our giant library analogy.
Okay.
They can instantly cross-reference every book to understand the meaning of a single sentence.
Wow.
And all thanks to a mechanism called self-attention.
Okay.
It's like they have a mental map of the entire library.
So they're basically like the Google search of the AI world.
Pretty much, yeah.
Right.
Now, state space models, or SSMs, they're a bit different.
Okay.
They're more like historians
Right.
who are really, really good at understanding long sequences of information. Think of them piecing together like a complex narrative from a massive timeline of events. They're particularly good at processing really long chunks of text. Right. Like if you're analyzing an entire historical document or a lengthy novel.
So transformers are all about speed and efficiency,
Mm-hmm.
and SSMs are the masters of like long-form content.
You got it.
Okay.
Yeah.
Now, here's the really interesting part.
Right.
This study found that those intermediate layers, those specialized sections of our library,
Yeah.
they often contain better representations of information than the final output layer.
Really?
Yeah, it's like finding this hidden gem in the back corner of the library that's even more valuable than all the bestsellers on display out front.
Wait, hold on. Are you saying that the AI might be overthinking things? Like it comes up with a brilliant idea in the middle and then kind of messes it up by the end?
Well, it's a possibility.
Oh.
And it has to do with how the models process and compress information.
Okay.
So the study looked at something called prompt entropy.
Prompt entropy.
Yeah. So imagine you give the model a sentence,
Okay.
like a prompt.
Hmm.
High entropy means that the model is storing a ton of detailed information about each word in that sentence.
Right.
Low entropy, on the other hand, means it's condensing things down,
Okay.
focusing on the most important patterns and connections.
So it's like the difference between someone who takes super meticulous notes on every single detail versus someone who just jots down like the key takeaways.
Exactly.
Gotcha.
And what's fascinating is that they found a link between this information compression and performance.
Interesting.
So they tested these LLMs on this massive knowledge test called MMLU.
MMLU.
Yeah. And guess what? A model called Llama 3, which showed more compression, so lower entropy in its intermediate layers, actually scored way higher than a model called Mamba 2,
Okay.
which had more spread out representations.
So it's not just about how much information the AI can like cram into its digital brain,
Right.
but about how well it organizes and prioritizes that information.
Precisely, it seems. These LLMs are learning that less can be more.
Right.
By compressing information effectively, they can focus on those key patterns and connections, which actually leads to better understanding and performance.
Wow.
It's a lesson we could probably all apply to our own lives, right?
Too true. But how did the researchers actually measure all this stuff?
Yeah.
We're talking about the inner workings of an AI.
Right.
That seems incredibly complex to even like track.
Oh, it is. They use some really clever techniques to peek into those intermediate layers.
Okay.
One method was looking at what's called curvature,
Curvature.
which looks at how much the direction of meaning changes between words.
Okay.
It's kind of like analyzing the plot of a movie.
Right.
You know how many twists and turns are there? how smoothly does the story flow?
Yeah.
Curvature in language is all about how connected the ideas are within a sentence or a paragraph.
Okay, I can kind of picture that.
All right.
What else did they use?
They also use something called augmentation-invariance metrics.
Augmentation-invariance metrics. Okay.
Yeah, think of it this way. You slightly change the wording of a sentence,
Okay.
like giving your friend a new haircut.
Right.
These metrics test whether the AI still understands the same core idea, even though the surface details have changed.
So it's like making sure the AI isn't just thrown off by a little rephrasing.
Exactly.
Okay.
And these tests, they revealed some fascinating differences between transformers and SSMs.
Like what?
Well, transformers, with their dramatic information compression, they actually showed lower scores on these tests when they were analyzing medical texts. It's like they were getting a little bit too focused on the specific jargon and sentence structure of medical language.
Yeah.
So any small changes kind of threw them off.
So maybe transformers aren't that great at adapting to like more specialized language.
It's possible.
Does that mean that SSMs are more reliable in like those kinds of niche fields?
That's a great question. And it's one the researchers are still exploring.
Okay.
But it does seem that SSMs, with their more consistent representations across layers, they're a bit more robust when it comes to handling specialized language.
Right.
They're not as easily thrown off by slight variations in wording.
So it's like transformers are the super focused specialists, and SSMs are more like general practitioners who can handle a wider range of cases.
That's a fantastic analogy.
Right.
And there's another fascinating discovery we need to unpack about how these models learn.
Ooh, do tell.
Yeah.
This is where it gets really mind-blowing.
Oh, it might just.
Right.
So they looked at the AI's performance at different stages of training.
Okay.
Kind of like checking in on a student's progress throughout a semester. And they found that the most significant changes in those key metrics, like prompt entropy and those augmentation invariance scores, they happen in the intermediate layers.
So the real aha moments,
Yeah.
the points where the AI is really making breakthroughs in its learning process are happening in those middle stages, not at the beginning or the end?
You're absolutely right. It really reinforces the idea that those intermediate layers are where the true magic is happening.
This is amazing.
It's where the model is grappling with information, making connections, and figuring out how to organize its understanding of the world.
This is blowing my mind. We've gone from giant libraries to AI historians to comparing LLMs to students cramming for exams.
Yeah, it's quite a journey.
And you're telling me there's even more to unpack in this study?
Oh, we've only just scratched the surface.
Come on.
And believe it or not, there's a real mystery we need to explore.
A mystery. Now you've really got my attention.
So remember that prompt entropy we talked about?
Yeah.
Well, they found something really strange when they looked at the distribution of those entropy values in some transformer models.
Okay.
There was this bimodal pattern.
Bimodal.
Yeah, like two distinct clusters of information. It's almost like the model had two separate ways of representing what it was learning.
Wait, so you're saying these AIs might have two different modes of thinking?
That's exactly what the researchers are trying to figure out.
Whoa.
They looked at all sorts of factors that might explain this strange pattern, like the length and complexity of the prompts, even whether the prompts were similar to the data that AI was trained on.
Right.
But so far, the answer remains elusive.
So a genuine AI enigma. I'm already itching to hear more about this, but I'm guessing I'll have to save that for part 2.
You know, we'll delve deeper into this mystery and explore some real-world examples of how these findings are impacting the development of modern AI. You won't want to miss it.
Can't wait.
So welcome back to our deep dive into the hidden layers of AI.
You know, I'm still trying to wrap my head around the idea of an AI having like 2 different thinking modes. It's like something straight out of Westworld, you know?
It's definitely one of the most intriguing findings of this whole study.
Yeah.
But before we get lost in like sci-fi scenarios, let's ground this in some real-world examples from the research.
Okay, yeah, let's bring it back down to earth a bit.
Oh.
You mentioned different styles of information processing between transformers and SSMs.
Yeah.
How did that actually like play out in the experiments?
Well, they used a few different types of data to test the models.
Okay.
One data set was based on general text from Wikipedia, kind of like a broad overview of knowledge.
Right.
Another data set was specifically focused on medical information,
Okay.
full of specialized terms and complex concepts.
Makes sense. So do those different data sets reveal anything interesting about how the 2 types of LLMs handled those different kinds of information?
Absolutely. Remember those augmentation-invariance tests we discussed?
Yeah.
Where they slightly tweaked the wording to see if the AI still understood the meaning?
Right.
Well, the transformers actually scored significantly lower on those tests when they were dealing with the medical data set.
Oh, really? So they were more easily thrown off by, like, small changes in the medical texts.
Yeah.
That's kind of surprising considering they're supposed to be the super efficient ones.
Exactly. It seems that their more dramatic information compression, which works so well for like general knowledge, might actually make them more sensitive to the nuances of specialized language. It's like they get so hyper-focused on the specific vocabulary and sentence structure of the medical field that any deviation from the norm throws them off balance.
So it's like they learned the textbook by heart,
Yeah.
but then struggle when, like, a patient uses slang or describes their symptoms in, like, a way that's unexpected.
Precisely.
Wow.
Whereas the SSMs, with their more consistent representations across layers, seem to handle specialized language more robustly.
Okay.
They're less thrown off by slight variations in wording, perhaps, because they haven't compressed the information quite as intensely.
Interesting. So maybe in those kind of specialized fields, like a more generalist approach to learning is actually more effective.
Yeah.
Like a doctor who's seen a wide range of cases versus one who's only read about them in textbooks.
That's a great way to put it.
Okay.
And there's another fascinating finding that's related to how these models learn over time.
Okay, tell me more. Is this about those intermediate layers again?
You bet they analyzed the AI's performance at different stages of training, kind of like tracking a student's progress throughout a semester.
Okay.
And what they found is that the most dramatic improvements, as measured by those key metrics we've been discussing, happen primarily in the intermediate layers.
So like the real aha moments, the points where the AI is really making breakthroughs in its learning process, those are happening in those middle stages, not at the beginning or the end.
It's like the AI is laying the groundwork in the early stages, then really grappling with the information and forming those deeper connections in the intermediate layers. And then by the time it reaches that final output layer, the heavy lifting has already been done.
This is really starting to paint a picture for me that those intermediate layers are like the engine room of the AI's learning process.
Exactly. And this has huge EE implications for how we think about designing and training these models. You know, if the intermediate layers are so crucial for performance, maybe we need to shift our focus away from just optimizing that final output. And pay more attention to what's happening in those hidden layers.
So instead of just like grading the AI on its final exam, we should be looking at its homework assignments and class participation to see where the real learning is happening.
A perfect analogy. But it's not just about training, it's also about how we use these models. If those intermediate layers contain such rich and nuanced representations of information, perhaps we can actually tap into those directly for certain tasks.
Okay, I'm intrigued. Give me an example.
Okay, so let's say you want to use an AI to summarize a really lengthy document. Instead of just relying on the final output layer, which might oversimplify things, perhaps we could extract information from an intermediate layer that's specifically designed for understanding and condensing complex information.
So it's like accessing different levels of understanding within the AI. Depending on like what we needed to do.
You're catching on quickly. This is an area of like really active research. And it has the potential to unlock entirely new capabilities for LLMs.
Wow.
Imagine being able to tailor the AI's output to different levels of detail or even for different learning styles.
Okay, now I'm really geeking out about the possibilities here. But before we get too carried away, let's circle back to that mysterious bimodal entropy pattern you mentioned earlier. Did the researchers shed any light on what might be causing it?
Unfortunately, that remains a bit of a head-scratcher.
Oh, no.
They explored all sorts of potential explanations, but none of them fully fit the data. They looked at things like the length and complexity of the prompts, whether the content overlapped with the AI's training data, even like the specific structure of the sentences.
And nothing.
Nothing conclusive.
So we've got ourselves a genuine AI enigma. It's almost like these LLMs are holding on to some secrets about how they really work.
It's certainly a tantalizing possibility. And it just goes to show how much we still have to learn about these incredible AI systems.
For sure.
But don't worry, we'll delve deeper into this mystery and explore some of the broader implications of these findings in the next part of our deep dive.
I'm on the edge of my seat. Okay, so we're back, and my brain is officially full of AI secrets.
I bet.
Let's wrap up this deep dive into the mysteries of LLMs, shall we?
Absolutely. We've covered a lot of ground
That's
from,
hard.
the surprising power of those intermediate layers
Yeah.
to that really tantalizing mystery of that bimodal thinking pattern.
Yeah. And speaking of implications, you mentioned that these findings have like huge implications for the future of AI.
Yeah.
Can you expand on that a bit?
Certainly. So one of the most exciting possibilities, I think, is the development of more efficient AI systems. If we can learn to harness the power of those intermediate layers directly, we might not even need these models with billions of parameters for every task.
Right.
We could potentially create like smaller, more specialized models that are just as effective,
Okay.
but use way less computing power and energy.
So it's like finding the right tool for the job instead of always using a giant energy-guzzling supercomputer for everything.
Precisely. And this ties into another intriguing possibility, which is personalized AI.
Personalized AI.
Yeah, imagine being able to fine-tune those intermediate layers
Okay.
to create an AI that's specifically tailored to your needs and your learning style.
Wow.
It's like having a personal AI tutor who understands exactly how you learn best.
Okay, now that is a future I can definitely get behind.
Right.
But let's be real for a moment.
Okay.
What are some of the challenges that researchers are facing in this area?
Yeah.
I imagine there are a few hurdles to clear before we're all like living in a personalized AI utopia.
You're right. There are definitely challenges. One of the biggest is understanding why those intermediate layers are so effective.
Okay.
We've seen all this evidence, but we still don't have a complete theoretical understanding of how they actually work their magic.
So we've discovered this amazing new continent of AI knowledge,
Right.
but we haven't figured out how to read the map yet.
That's a perfect analogy. And until we have a better map, it's really difficult to fully exploit the potential of these discoveries.
Right.
Another challenge is developing new tools and techniques
Right.
for actually analyzing and manipulating those intermediate layers.
Okay.
It's a super complex and rapidly evolving field, and we need better ways to visualize, interpret, and control what's happening inside those hidden layers.
Sounds like there's plenty of work to be done for those brilliant AI researchers out there.
Absolutely.
But knowing how fast this field moves,
Right.
I'm sure they'll be making incredible breakthroughs in no time.
I think so too. The progress being made is really remarkable. And as we gain a deeper understanding of these models, we're likely to see a wave of innovation in AI applications that we can barely even imagine today.
Okay, so before we wrap up this mind-blowing journey, can you leave our listeners with one final thought-provoking question to ponder?
Absolutely. So we talked about the possibility of LLMs having these two different modes of thinking.
Yeah.
What if those modes aren't just a quirk, but like a fundamental feature?
Right.
Could we learn to control those modes, to switch between them like gears in a car, depending on the task at hand?
Well, that's a truly mind-bending thought.
Right.
It's like having an AI that can adapt its thinking style to different situations, becoming more creative or analytical as needed.
Exactly. And that's the beauty of all of this research. It pushes the boundaries of what we thought was possible with AI. And it opens up these entirely new avenues of exploration.
Well, a huge thank you to our expert for guiding us through this incredible deep dive into the world of LLMs.
Oh, it was my pleasure.
It's been a wild ride. And to our listeners, keep exploring, keep questioning, and stay tuned for more fascinating journeys into the ever-evolving world of technology.
Until next time.